I am pretty sure that you have seen a Newton fractal before, but have you seen the 7 beautiful examples that I'm going to show you in this video? In this video, I will not explain mathematical details or technical details behind Newton fractals. I'll just give you a bit of intuition for each of the examples that we will look at. So here we go. To show you what a Newton fractal is, here is the first example. And as I told you, in each of the examples that I show you, we'll focus on one particular thing that you can clearly see. So the first thing I want to point your attention to is colors. In this picture you see 3 different colors. There is a red, there is an orange, and there is a yellow tone. But there is something more to that. If you look at a picture of a Newton fractal, usually you see more than just a simple color. You see a color shading, and that's what I show you here. So this is the same fractal as before, but this time instead of just a single color, I've shaded the color in a particular way. My name is Andreas, and I like to think about stuff, take stuff apart, question things, investigate in detail, try and play around with stuff until I understand something. So if you are like me and you would like to understand more about different things, just post a comment below and let me know what it is that you'd like to understand better. So maybe we can explore it together. In example number 2, I show you a Newton fractal that is more complex than the first one. In particular, there are more colors in this picture. To be exact, there are 12 colors here. For the moment, it's not important how the number of colors depends on the underlying mathematical structure of the fractal. Let's just notice that there can be different numbers of different colors in the picture. In example number 3, I would like to point out another feature of Newton fractals, and that is their structure and also their symmetry. This picture very nicely shows you a 4-fold symmetry on first glance, but it also shows you a lot of structure in the picture. And it's noticeable that the structures exist on different scales. You probably already know about fractals, that no matter how far you zoom into them, you still see structure, and the structure sometimes seems to repeat itself. In example number 4, I will give you an example of this kind of structures that appear inside structures. So let's zoom into a part of this particular Newton fractal and have a look at what is visible. You'll notice that not all of these structures are alike. Some of them are very different and some of them are very similar. Example number 5 shows you another possible feature in the Newton fractal, which is periodicity. You can see structures that repeat and repeat and repeat, both on different scales and also in different directions. After zooming in on this line of structures that is vertical in this picture, I move along and you can see that they repeat on different scales in different distances and also in different sizes. By the way, if you're a curious person like me and love to understand things better, then hit the like button so that I can make more interesting content for you like this one in the future. In example 6, you can clearly see another very famous property of fractals in general, which is self-similarity. In this particular Newton fractal, you can see several regions that look alike. For example, this one, or this one, or that one. While we have already seen several very different shapes and Newton fractals in this video, I want to show you another example in example number 7, which shows you that already inside a single Newton fractal there can be various shapes and completely arbitrary shapes at that. So just by changing a little bit here and there in the generation of the fractal, you can generate a number of very different and very interesting pictures. Now that you have a good intuition about Newton fractals, it will be much easier for you to understand what's behind them and how they are created when I explain that in another video.